Good afternoon, everybody. Welcome to today's broadcast. We're going to talk a little bit about CloudFormation and how we use CloudFormation to manage our customers' environments. We're going to keep it really simple today and just talk a little bit about building a virtual private cloud, a VPC. So we're just going to dive right in and have a look at the content here. So this is what we're actually going to build. Really simple VPC. If you tuned in last week, you would have seen the diagram similar to this around workspaces. What we've done is just pulled out some of that info from the workspaces demo and just built out a multi-AZ, 2AZ VPC with the components that you need to help protect your workloads, things like NAT gateways, so that your infrastructure is private and you can limit what's in your public subnets. You can also see we've added VPC flow logs here to give us information about what's flowing in and flowing out of that VPC, whether it's accepted or rejected traffic. In this demo, we're going to connect flow logs to CloudWatch logs. You can also connect it to S3 if you'd like. Okay? So this is what we're going to build. Before actually getting into the build, though, we do have just a few little slides to walk through as a bit of a intro to CloudFormation, and then we'll get into the demo and walk through kind of how we build out our templates and how we deploy them. A template is really nothing more than either a JSON or a YAML document, and all you're going to do within that document is describe the resources that you want to deploy and the configuration of those resources. There's a number of sections that typically would exist within a CloudFormation template, regardless of whether you're using a JSON or YAML structure. But you can see in the list here, only the resources section is required, and that's probably where you're going to spend the majority of your time. This is where you're going to, in our example, define our VPC, define the NAT gateways, the subnets, all the route tables. Okay. You can also create a metadata section. This is to tell you a little bit about what the template is, the resources in the template. Parameters we're going to talk about in a little more detail here in a second. Mappings, think of these as key value pairs. If you're running, one of the goals with CloudFormation is always to build your templates in a way that is flexible, so that you don't end up having to create templates for every deployment across different accounts or different regions. So a really important tool there is mappings, because you can say, if you're going to run this template in, let's say, US East 1, use this AMI, versus say CA Central 1, use a different AMI for your EC2 instances. And the easiest way to do that is with a mappings section. Conditions, these are just if statements, right? So I'll give you an example of these as we dive in, but it's a really simple way, again, to make decisions or allow CloudFormation to make decisions when it's interpreting the instructions in your template based on parameters or other inputs that you've passed. I mentioned the resources section already, and the transform section is, I think, still relatively new, but it allows you, basically, think of it this way, to run some macros. And looking at this slide now, it's either cut off, or I forgot to add it, an output section. So outputs are just like it say, when you create an EC2 instance, you can output information about that EC2 instance or any other resource that's created as part of the template. And we'll talk a little bit about why that might be important later on. So that's the basic breakdown of a template. I'm going to show you the way we construct our templates here in a minute. Parameters, probably a very important concept. Think of these as just variables. Basically, it allows us to pass information into CloudFormation that CloudFormation will use when it's executing the templates. You can then override those variables by basically changing them in the console or at the command line using a parameter override option. I've got a little snippet here of one of the templates that we're going to look at. We would often add tags, or you should always add tags to resources that you're deploying, whether you're doing that manually or through something like CloudFormation. In the way that we operate, we would always use a series of tags. Environment, right? Tell us, is it production, is it development, or maybe staging? Who owns it? And also, how could we contact that owner in the event that we needed to ask them something about this resources? So this would be a standard template, or a standard parameter that we always put into every template, and then we may augment that depending on what we need to do. And you can see in this example, we've got default values set for everything. The environment is a little different. You can see that we've got an additional option there called allowed values. If you're looking at this in the CloudFormation console, it would just provide you with a drop-down list. And you could select either production or development. If you're deploying this through some sort of maybe CLI or some sort of custom script, if you put anything other than production or development, it's going to kick back an error and tell you that the value that you've provided is not allowed. This is a great way to help ensure that your templates operate the way that you would expect. Now, there's a lot of components in a standard template, and one of the ones that you'll use a lot of are intrinsic functions. So I've got a list here of some common functions. Again, by no means meant to be a complete list. You can have just a quick look. If you Google CloudFormation intrinsic functions, it'll dump you right onto the documentation page, and you can see everything that's there. But in this example, you're going to see these come up in the templates that we're going to demonstrate today: a reference, or a reference, a join statement, a substatement, and then there's also some functions like getAZs as a way to, again, build more dynamic templates. Instead of hard coding availability zones in your templates, you can use an intrinsic function, and when the CloudFormation engine interprets that template, it will substitute in those values. Again, more flexible solutions. Pseudo parameters, again, something that is really important for you to build out flexible solutions. These are parameters that are defined by CloudFormation. Okay, so unlike the parameters that we looked at earlier on, I can put whatever values I would like into those parameters. A pseudo parameter is set on our behalf. Some common examples of parameters: region, account ID, stack name. I'm going to show you some examples of these again. So really important tools to make those templates flexible so that you can run them across multiple accounts and multiple regions. Here's a snippet of a template, and we've got a resource defined here. In this case, you can see it's a launch template that we've defined, and then we've got all the properties, basically the configuration of that launch template. And you can see some examples of both pseudo parameters as well as intrinsic functions in this little snippet of code. We've got a find in map intrinsic function. I mentioned the mappings already, right? If you're running in region A, use this AMI. If you're running in region B, use a different AMI. So we can use the find in map intrinsic function to refer back to the definitions, the key value pairs that we've created in the map file. In this example, my mapping its logical name is called AMI map, and then we use a pseudo parameter. So wherever this person is executing this template, we're going to substitute in the region and use that information to find the appropriate AMI to use in our example for a web server. We've got a couple intrinsic functions like referring to parameter values that we've passed in, our instance type, our key pair, and then at the bottom you can see we've got another interesting combination of intrinsic functions: import value and substitutions. We're going to come back to that in a second. It's also important to note that when you create a template and you execute that template, CloudFormation is going to, as much as it can, deploy all of those definitions that you've set up in your template in parallel, okay? Which makes a lot of sense. If you end up with a lot of resources, it would take a long time to deploy those in sequence. So it's going to, by default, operate in parallel. In some cases, though, you might not actually want that. So there are a couple specific resource parameters that you can define to help control the order in which, or the timing that CloudFormation is going to use when it deploys your resources. So it depends on attribute. It's just like it says, right? It allows you to control the order of resources being deployed within the template. So a really simple example: the EC2 instance depends on the RDS database. So you can set that up in your template. CloudFormation will look at that and say, okay, well then I need to do the RDS database first. Once that's done, then we'll create the EC2 instance. You also have a wait condition. This is really a very simple timer. More appropriate in many cases is a creation policy. Creation policy is kind of like a wait condition, but I would say on steroids, right? You can set up basically a number of success signals. A great example is, let's say you've defined an auto-scaling group in your CloudFormation template. What you could do is say, well, wait to get, let's say you've defined your auto-scaling group with a min and a max of, 4. Okay, so we could define our creation policy to say, wait until we get 4 success signals before continuing. Okay, if it doesn't get those 4 success signals, it will stop. let's say you get 3 success and 1 fail, it would stop. You can also set a timer. So basically a timeout, right? If I don't get 4 success signals within 15 minutes, I'm going to stop right here. And in the event that we've got it configured, it'll do a rollback automatically. Once you've deployed your resources, most likely you're going to have to maintain those resources over time. The most important aspect about this is once you've deployed resources via CloudFormation, you should maintain those resources through CloudFormation. Okay. If you start making changes to resources outside of CloudFormation, now you've got a situation where the templates are out of sync from what's actually deployed. And 9 times out of 10, that's not a big deal, but every once in a while, if you try to make a change to the template in the future, that may actually hang up the process and you end up having open support tickets and all that kind of good stuff. So once it's deployed through CloudFormation, maintain it through CloudFormation. Once you're running update commands, it's really important to understand the effect of updating a resource that's already been deployed through CloudFormation. You can look in the documentation, but basically I'm going to sum it up like this. You can make a change with no interruption to that service. You can make a change with some interruption, or you can make a change that causes that resource to be basically recreated. The first two aren't necessarily issues, right? Some interruption might be acceptable, but replacing a resource, you most likely don't want that to happen in many cases. We have lots of ways to understand the effects of changes that we want to make prior to making those changes. So we've got change sets, we've got update policies, we've got update replace policies, and we've got stack policies. So change sets are super important. I can tell you that this has saved my butt on more than one occasion, maybe where I'm working a little later than I should be and I accidentally typo something in a CI script and I deploy, let's say, the Route 53 template and I give it the EC2 stack name. Without a change set, CloudFormation is just going to say, okay, yeah, I know what you want me to do. You want me to remove all these EC2 instances and replace it with a zone in Route 53. Probably not what you intended. So a change set is a really important tool. The way that I describe it is it's a dry run. If you were to execute the changes that you've defined in this template, here's what CloudFormation would do. And it's going to basically tell you, am I going to replace this resource? Yes or no. The less clear option it'll give you, or response it'll give you every once in a while, is a conditional situation, and you can dive into the change set to understand exactly what's changing. So do this. Okay, and I'm going to show you how we do this with all our templates here in a minute. Once you look at the change set, you can determine whether or not this is what you expected, and then you can execute the change set, delete the change set, or actually push another change set in if you notice something that you didn't expect. Super important. Another important attribute is the update policy. This allows us to tell CloudFormation how we want it to handle updates to supported resources. Okay, so as I mentioned here a couple times, not supported by everything within Amazon, or all the resources that you can define within CloudFormation, I should say. But again, an important tool to help you understand if an update is going to occur on this resource, how will CloudFormation handle it? You've also got an update replace policy. In the event that you make a change that CloudFormation has to replace that resource, you can tell CloudFormation what you want it to do before replacing it. Okay. And again, like the previous attribute, not supported by all resources that you can define within CloudFormation, but you can do things like retain it, you can snapshot it. I'm missing one other one I can't remember off the top of my head here, but you have options. So these are really two important tools or attributes that you can define within your templates to help protect your resources. Speaking of protecting your resources, a couple other special attributes. The first is a deletion policy. This works very similar to the update replace policy. If I'm going to delete this database, okay, maybe I run a delete stack command against my RDS database stack. I maybe don't want to just delete it. Maybe I'm going to snapshot it first and then delete it. Okay, so the deletion policy allows you to do that. There's also a stack policy that you can define on your stacks, and this is really nothing more than a JSON document. It looks very similar to, or actually it is exactly the same as an IAM policy, so you've probably all seen those, and it allows us to create action, effect, and resource definitions, again, to protect the resources that are deployed through CloudFormation. One of the most important aspects of building anything, whether it's a simple VPC like we're going to do here in a second, or an entire application stack, is understanding the strategy that you're going to use to create the stack, or in many cases, multiple stacks that are used to deploy that solution for your customer. So you've got some options, right? You could just create everything in one giant template and deploy it. It's an option, but I wouldn't suggest that you do that. What normally happens is you end up with quite large templates, and they become difficult to maintain. A new person joins the team, and you want that person to take over the maintenance of that template. It takes them longer to get up and running. So you want to make sure that you create things that are easy to change. People aren't reluctant to actually make changes because they're easy to understand. So that leaves us with really two other options. You can break your application or your solution down into layers, or you can even take a microservices approach and break your templates into very small, discrete pieces of code that do one specific thing and nothing else. Okay. The last thing you can see here on the slide is, you're going to have to experiment a little bit, find the strategy that works for you and your team, but regardless of where you end up, make sure that all of the templates are stored within a version control system. Doesn't again matter what version control system you use, as long as all of the templates exist in one repository that you can manage access to and understand the changes over time. If you go down the layered approach or microservices approach, or some combination of the two of those, you need to figure out how you can tie your different stacks together. And you really have two options. You have nested stacks or chained stacks. I mentioned earlier on that one of the first slides that I didn't have the outputs section in there in the template. And this is where it becomes really important. Outputs from one template can become inputs for another template. Okay. I always get the terms mixed up, so I apologize if I send you down the wrong path here, but in my brain, we use chained stacks, and I'm going to show you that. Outputs from one template now become inputs for another template, and the way that we do that is through exports. So if you think back to the little snippet that I had, we had an intrinsic function there called import value, and that's actually looking at the exports that are coming from other templates or other stacks, and we're pulling those in to the other stack. I'm going to show you an example of that. And then I think this is the last slide, and we'll get into the demo. Drift detection. This is a relatively new feature of CloudFormation. I mentioned earlier on about the importance of maintaining resources in CloudFormation once they've been deployed through CloudFormation. Drift detection is something that you can run against your templates to help understand if something has changed, right? You deployed a security group through CloudFormation that opened port 123. You do a drift detection, and what will happen is CloudFormation will say, well, now the actual security group says port 1234 is open, and it will highlight that as drift. And then you can drill down in and have a look at exactly what changed. Okay. In a future broadcast, we'll talk about things like config and CloudTrail. With drift detection and config and CloudTrail, all of those services running, you could work backwards now and understand who made that change and when they made it. And I always like to say that that's an opportunity for education at that point, to let that person know that, hey, they might need that change, but really it should be managed through the CI process, whatever that process looks like that you've created for your CloudFormation templates. So that's the amount of slides that I wanted to go through. What I'd like to do now is show you the actual deployment of these environments. So let me just shut this off, and we're going to go back to PyCharm. So I know it's a little small. I couldn't figure out before on the left-hand side here, my editor, how to make that a little bigger. So the code itself will be bigger in the editor, and I'll walk you through how all this works, and then you'll see how we deploy it through CloudFormation. Okay, so let me just make sure that's ready to go. And what we've got here are, we kind of move between a layered approach and a microservices approach. In this particular example, we've got a number of templates that we've created. I'll open them all so we can see them easily. I like to separate the different components for the resources that we're deploying, again, because managing a CloudFormation template that's 40 lines long is way easier than managing a CloudFormation template that's 400 lines long. In this template, you can see all we're doing is we're deploying IAM resources that are specific to the features that we want to enable within the VPC that we're going to deploy here in a second. We've created a role for flow logs, right, to meet that requirement, and we've set up the policy that we want to associate with that role that allows, in this case, the service flow log to basically communicate with CloudWatch logs. And here's our first example of outputs. When we run this IAM template, we need the ARN associated with the flow log role for another template. Okay, so this is where the export value comes in, and you can see that we're using an intrinsic function substitute, but we're also using another pseudo parameter, in this case stack name. So we don't have to hard code anything here. And I'm going to show you how we do this in our simple CI scripts here in a second. Assuming that everything goes well in the IAM deploy, we can then move on and do our actual VPC. This is a larger template. You can see if I just scroll quickly, it is still 300 lines long. We could separate this a little bit, but this is where trying to find the right balance may come into play. Depending on the size of the deployments, we may actually take, if I scroll back here, see all the route tables? So we've got the route tables, the associations, the routes themselves. In more complex environments, we would actually break this into its own template. So we would have a VPC template and we would have a VPC route template. For this example, I left everything in one shot. Okay. But you can see again, we're defining owner, the owner email, the environment. So we're pulling in those parameter values, and then we're using intrinsic functions like join, sub, pseudo parameters. And ultimately what we're trying to accomplish here is that I can take this template and I can create a VPC in multiple AWS accounts across multiple regions and not have to make any changes. If I scroll to the very top of this, you'll see the parameters section. And we've got a number of parameters defined here. Okay, so they all have default values. In our CI script, if a customer would say to us, well, our network needs to be 10.20, let's say, we wouldn't change this. We would simply override the parameter in the deploy command, which I'm going to show you here in a second. And then the final template that we have here to build out that reference architecture is the flow log template. So why is the flow log template separated from the main VPC? Even though, CIS benchmark would say VPC flow log should be enabled on every VPC within your account, in some situations, we may have a customer that just says, hey, you know what, that sounds great, but we don't need it. We've got another tool that's doing the monitoring or something like that. So this gives us flexibility that we don't need to deploy the VPC flow log feature with every VPC. Okay. And you can see parameters here, we're pulling in stack information. This is important because if you look down here on line, where's the first example of it? Line 21, we're running the import value intrinsic function, and we're pulling in whatever we passed as a parameter for the IAM stack. This corresponds to the name of the stack that deployed the role that we saw earlier on. Okay, so a really simple series of templates that we can use to actually deploy our VPCs. The final piece is we use GitLab. Okay, so I mentioned earlier on, you need a centralized version control system. There's lots of options out there. We landed on GitLab, to be honest, because we had a customer that was a huge fan of GitLab, and we started using it to help them and realized that we actually really liked using the tool. So we've just adopted it as our own. You could use GitHub if you would like. You could use Code Commit, Amazon's managed service. It's up to you, okay? Depending on, your level of comfort, the costs that you any budgets you might have to adhere to. We picked this, and it's kind of our go-to tool. So the way that we work is we have our own GitLab deployment in a separate AWS account. Okay? And what happens is when we run this deploy script, that GitLab instance will basically use a role. It assumes a role in the other account to deploy the templates. Okay, so I'm going to actually, instead of just going in and forcing a pipeline to run, I'm just going to make a really simple change here to force the pipeline to rebuild. So I'm just going to do, okay, let's see if this will work. Okay, I know you can't see this the way I'm sharing my screen, but I'm basically just making a quick push to our repo. And that should fire off the pipeline for our demo. And I did run through it a bunch of times, so I'm hoping that the demo gods don't get us here. All right, so there we go. What you should see here is a number of templates pop up. So there's our IAM template. There's our VPC template. And there's our flow log template. So our CI pipeline is finished now in our GitLab deployment, and you can see that actually nothing has been deployed. They're all in review in progress. So what's that mean? That is an example of how everything is built. Let me actually flip back to PyCharm for a second. If I were to scroll down in our CI script, you can see that all we do here is when we assume the role in that account, and in this example, it's into our dev account, we simply run a series of AWS CLI commands. So you can see every block, every stage of this pipeline looks exactly the same. We're just deploying different components that we've defined earlier on. What we've got here is the deploy command, and what we do is we basically generate a change set. Okay, so even on the first deploy, nothing happens. It's waiting for us to validate the change before going forward. So if I go back over to the console, whoops, give me 1 second. There we go. I've selected the IAM stack. We know that that's the first stack that needs to be deployed because the other resources that we have rely on it. And we're in review in progress. If I go over and look at change sets, I have a single change set. If I click on the change set, this is what I was mentioning earlier on. Okay. Now we know everything is going to be add here because we've never deployed this before. So the action is add. Over here is the column that I mentioned earlier on. Am I going to replace this resource? Yes or no? So it's going to basically say true or false here. That's it. This all looks good to me. I'm going to go ahead and say execute. And when that happens, now I can see my events console, and very quickly we'll have the IAM roles that we need. Okay, so we'll just give this a second to complete. So there's the policy. And it always takes longer while you're waiting, doesn't it? And there we go. Okay, so the IAM stack that we use to deploy basically the IAM resources that we need for our VPC configuration has completed successfully. If I go to the output section, there is the role information, the ARN associated with the flow logs role that we defined. And you can see here, there's the export name. That was constructed by CloudFormation by using the pseudo parameters that we provide, right? The stack name pseudo parameter. So you can see there's our stack name, and then we appended to the end flow logs role. That means that since this is done, I can then go ahead and do the actual VPC, and you'll see the same situation. Here's my change set. Obviously, a lot more resources here to build out the subnets, the route tables, the NAT gateways, all of that good stuff. I'm going to execute this. And again, as long as the demo gods don't turn on us, we should have a VPC here in a couple minutes. So as we're waiting for this, what I'm going to do is I'm going to go back and I'm going to make a change to, what can I change easily in IAM? Just give me a second here. Yeah, okay. Hold on one sec. Let's make sure this is still running. Okay, there we go. So we've got our route tables. Everything's been deployed here, and it's finishing up. So we'll give that a couple more seconds. Let me bring, let's go back to PyCharm. And I'll show you a couple things. We mentioned the depends on attribute earlier on. There's a number of depends on attributes defined or parameters defined within this template. So here's our first example. Here's the VPC, right? And the configuration of that VPC, pretty basic. You can see that we refer to a parameter earlier on to get the CIDR notation for the VPC. The second thing that we've defined here is the internet gateway. Well, we know that an internet gateway, I guess we could create an internet gateway and not associate with anything, but not really much point on that. So we want to make sure that the internet gateway doesn't get deployed until the VPC has been deployed. So there's our first depends on. If we go down here, once we've defined the internet gateway, we have to associate or attach it to something. In this case, we don't want the attachment, the VPC gateway attachment command to run until both the VPC and the internet gateway itself are defined. Okay, so these are some simple examples of how you can use depends on. Now I wanted to go here, and what we're going to do is we're just going to go something like this. I know it doesn't make any sense, and I'm not even sure if this is syntax correct from a syntax perspective. There we go. But we're just going to say, hey, allow flow logs to stop instances. You would never do this in real life, but it's going to illustrate the point. And all I'm going to do is I'm going to make another commit. Okay, and we'll just say update policy. And we'll push that into the repo as well. Okay, so let's go back to CloudFormation. And you can see CloudFormation still doing its thing. See where we are. Okay, it's done a bit, still progressing. But if we go back now to our IAM stack, as long as I didn't mess anything up, there we go. We've got a new change set. And if we click on that, now we can see that we have a modification action that's going to run against this logical ID. So that's the name that we gave it in our template. Here's the actual physical representation, so the ARN for that resource. If I click that, let's pull it up in another tab. So pretty basic policy, right? We're just giving flow logs, the flow log service, access to CloudWatch logs. So you can see our JSON policy right now. We're gonna say, yeah, this is what we wanted. It's not gonna replace the policy or anything, so let's execute the change. So we can do that in parallel while we're waiting for the other one to complete. Okay, and this should just be really quick. Yeah, maybe not. Well, you can see the VPC is deployed, so we'll go back to that in a second here. Let's give this one more sec. There we go. Okay, so our update operation has been completed. Now, if I go here, and actually, let's do it this way. Just so I can make sure that I get the right thing again. We looked at the policy, right? Yeah. So now we should see that permission change. So there we go, EC2 stop instance. So now the VPC flow log service could stop an instance within our environment. Okay. I'm going to remove that just so that it's out of the demo, and we'll just repush it, but we won't wait for it. Okay, so the last piece of our deployment is the flow logs. So like we've seen in the others, we can go now and we can execute this change set. So at this point, oh, look at that. Always something, right? Okay, so we can fix this. So we're going to let it fail. There's our rollback. I ran this earlier on to make sure that it would work, and I didn't actually clean up the log group, which is interesting. I'm going to have to go back and have a look. I'm not sure why that's still there. So we're going to delete this, and you'll see that we get this. This is another piece of our standard CI deployment. There's another CloudFormation CLI command that allows you to enable termination protection. The way that I like to think about this is, in Windows, right? Delete the file. Are you sure? This is kind of the same thing. And you can do termination protection on a bunch of other resources like EC2 instances, load balancers support it. So we're going to say, yeah, we're okay with this, and we'll delete it. Okay, so there, we're cleaned up. So let's go and see if we can fix this. So I think it complained about a log group that didn't get removed for some reason. So let's go to CloudWatch logs. Here's our log group. And you can see it right here. I'm not quite sure why it didn't get deleted by CloudFormation. That's interesting. But we're gonna blow it away. Confirm that that's okay. Okay, so that's that. What we'll do is, in order to re-push this, actually, I'm going to make that IAM change, because that'll actually fire the pipeline off again. Okay, so that's done. We'll just give it a second, and we should see it pop up here. If everything goes according to plan. Yeah. Pushing my luck a little too much, I think. Oh, there we go. Okay, perfect. So let's have a look at this change set. We're adding the flow log and the log group. Let's see what happens now. There we go. That's better. So there's the log group, and there's flow logs done. So at this point, we have finished our demo VPC. 2 public subnets spread across multiple availability zones, 2 private subnets spread across multiple availability zones, each of those subnets having their own route table. So that gives us really granular control on how the traffic is routed in and out of our environments. NAT gateways, right? Managed services here that allow any resources deployed within our private subnets access to the public internet without having public IP addresses. And then logging of all the traffic flowing in and flowing out of our VPC, and we're storing that in our CloudWatch logs solution. So let's just have a quick look. We can go here. We'll go have a look at the VPC itself that we've just created. Okay. There's the VPC. There are 4 subnets, so 2 public, 2 private, spread across different availability zones. Individual route tables. So at this point, we have a functioning VPC. If we were doing this for a customer, then what we would do is we would augment this with additional templates, the templates that would be used for the other services that we would need, like S3, EC2, load balancing, depending obviously on what that customer requires for that solution. Okay. So that gives you a little bit of information on our workflow. We take kind of a mix of a layered and microservices approach for all our CloudFormation templates. The goal for those templates is to make them as specific as possible without kind of overkilling by creating a ton of really, really small templates. The goal is that they're easier to maintain, they're easier to understand, and it gives us flexibility on deployments for our customers. Okay. And we also demonstrated a really simple CI example using GitLab when we check our templates in, that it assumes a role in the account that we define. Excuse me, the account that we define in the CI script itself, and then once it's assumed the role, it runs a couple different CloudFormation commands, like a deploy command, a termination protection command within that deployment process. The last thing I want to show is we're just going to do an extreme change here, and we're going to modify something that we know we can't change without forcing a resource to be deployed. So all I'm going to do is if I go back to PyCharm, okay, I'm in my, let's get rid of some of these guys. I'm in my VPC, and we know up here that we've defined a default value, right? So our VPC itself, the CIDR notation is 10.10.0.0. I can't change this. Okay, if I change the default value, when I push this change, it actually won't make the change because it's just a default. Okay, what I have to do is I have to go into my template here, or in my CI script, and right here I'm going to say parameter overrides, and I want to say it was just VPC CIDR, but I'm going to cut and paste it. Okay. And we're going to say this is now 10.20.00/16. Now I think that's enough to force, obviously, a change, but I just want to show you what the change set looks like. Okay, so now we've got this defined. I'm going to go ahead and I'm going to push this change again. All right, so that's on its way. Actually, let's go here and just look at this log group while we're waiting for this pipeline to run. So there we go. So we've already got some captured data. These would be off of the NAT gateways, I'm assuming, because that's all that's here. Interesting, eh? Within a couple minutes, we can see traffic flowing. And look at what it is, 3389. Huh. That didn't take long. Okay, so let's see here. We go back. CloudFormation. Oh, sorry. I forgot to change my, you guys didn't see that. Let me come back. I went into CloudWatch here, and I just wanted to see if the log group was working. So there's our log group, and I mentioned that we can see traffic already, right? So these are the ENIs that are associated with the NAT gateways that we have. Okay, so they're already getting interesting traffic hitting them. But I wanted to show you this one last thing. So if I go to VPC, we should have a change set. Okay, there's our new change set. Oh, you see these failed ones? What we do is, because we don't really have, it's not a super complex CI deployment, it just says, hey, every time you check something in, just deploy all the files again. Okay, and there's probably a better way or a more efficient way to do that, but this works. What it does is in the first example here, there were no changes to be executed. So what happens is CloudFormation generates the change set, but the status of that change set has failed because, well, there aren't any changes to execute. So in your deploy script, you actually can put a I can't remember what the option is. Something about not stopping on a failed change set creation. It just keeps going through the other stages to make sure that everything gets done. So that's how we handle it. Pretty basic, but it works. This is what I wanted to show. Okay, so now you can see that one little change where I modified the CIDR range for the VPC. We know that a VPC, the subnets, the VPC itself are immutable. Once we deploy them, we can't change them. Now you can see the effects of this change. It basically is going to replace a lot of resources. And this is why I think change sets are so important. I could look at this and go, wow, that's not what I expected. I thought I would just see a change on a tag value on subnet XYZ, right? You look at this, you know it's not right. So you have one of two options. You can go back, make a change to your template and re-push it. And what would happen is you would end up with another change set. And if that change set looks okay, you can execute that change set. In my case, what I'm going to do is I'm just going to say delete. Now, this isn't deleting the stack. It's deleting the change set. Okay, so it didn't actually make any changes. I still have my failed change set, but I don't care about that. It'll get scrubbed out pretty quickly, actually. But now I can say, hey, you know what? I didn't mean to make that type of a change. You can delete that change set and go back and try it again. Okay. So that's it for today's broadcast. I hope you learned something. We'll be publishing this on the YouTube channel, so if you wanted to go back and look later, it'll be up in our YouTube channel probably over the weekend. So I hope that was informative. Stay safe, and we'll see you next time. Bye, everybody.